So, good morning, greetings. My name is Mr. Alvil Moses, and welcome to the most detested and complained about subject. But I would like to assure you that mathematics is the easiest subject ever you can have. It is the most fun and interesting subject. So you just need to change your mindset toward the subject. So it is the easiest subject to study, easiest to pass, and yet it is the easiest subject to fail if you're not serious. So you need to get serious, you need to like the subject, just change your mindset and work toward it. So if you're not serious, you will fail it. So today we are still busy with algebra, whereby we will look at solving linear inequalities. And at the end of this lesson, you should be able to solve linear inequalities in one unknown. So to take you back to grade 8 and 9, just to refresh your mind, you have learned about or what an algebraic expression is, and also how to simplify them, whereby we simplify them by collecting like terms. That's how we simplify algebraic expressions. Maybe if you are given, let's say, 7x plus 1 plus x, to simplify that, you will say 7x plus x equals to 8x plus 1. That will be the simplified form of that expression. And so you have also learned about simple linear equations, whereby you have also learned how to solve them. And you have also learned how to represent inequalities on a number line. So today we will look at how to solve linear inequalities, and also how we arrive to those inequalities we presented on a number line in grade 9 and 8. So those three skills you have learned in grade 8 and 9, they are very crucial, and they will help us to understand solving linear inequalities. So if there is no any question about what we have learned in grade 8 and 9, that is algebraic expression, how to simplify them, and also how to solve linear equations and represent the inequality in a number line, we can move on to today's topic, which is solving linear inequalities. So linear inequalities are similar to linear equations. The only distinction is at the sign that separates the two expressions. So remember, in linear inequality and linear equations, there are two expressions that are separated either by an equal sign or inequality sign. So for linear equations, they are separated by an equal sign, which means that the two sides or the two expressions are equal to each other. So if we have, let's say, 2x plus 5 equals to 11, this is a linear equation. Since we have an equal sign here, it means these two sides, they are equal. And so for linear inequalities, the two algebraic expressions are not equal. It means the two sides are not equal, and therefore we use inequality signs, which are here. We have they are just four. The first one is less than, second one is greater than, and this one is greater than or equal to, and we have less than or equal to. So we use those to separate the two expressions in linear inequality. So the two sides are not equal. So in this case, if you have 2x plus 5, you can either say greater than 11. This is an inequality because we have an equality sign. So that's the only difference here. For linear equations, the two sides are equal, and for linear inequalities, the two sides are not equal. So the four inequality signs, we can also, the first one is read as less than or less than, greater than, and this one is greater than or equal to, and the fourth one is less than or equal to. So for the first two, less than and greater than, let's say we have x less than 2 and x greater than 2. It means x can be any value less than 2, or x can be any value greater than 2. So it is either strictly less than or strictly greater than. And for these two, let's say we have x greater than or equal to 2 and x less than or equal to 2. This one means x can either be, 2 can either be, x can either be less than 2 or can be equal to 2. And here x can either be less than 2 or can be equal to 2. So it means here the number is included. So x can be equal to that number, or can be less than, or can be greater than. And when it comes to representing these on a number line, for the or equal to, we use a full circle to represent a number line. And for these two signs, we use an empty circle. So let's say if we were to represent x greater than or equal to 2 on a number line, since we have greater than or equal to represent this on a number line, we have to use a full circle. So we say, let's say this is our 0, then we have 2 here. So x has to be all the numbers that are greater than or equal to 2. So x is on that side. Okay? And for x greater than 2, we have that to represent it on a number line, we say this is our number line starting from 0, and here we have 2, then we have 3, and it goes on. So we start here. Since we have this sign means x has to be strictly greater than 2, we have that, we have to represent that with an empty circle. Then we say all the numbers that are on the right side of 2. So that was it for representing inequalities on a number line. So the rules for solving linear inequalities are similar to those used for solving equations. That's why I said it is crucial for you to understand how to solve linear equations. So we solve linear inequality the same way we solve linear equations. There are, however, some important exceptions for multiplication and division. So if you multiply or divide both sides of an inequality by a negative number, you must change the direction of the inequality sign. So let's say maybe you have negative 2x greater than 8. So that means you have to divide both sides by negative 2 to find the value of x. If you divide by negative 2x, divide by negative 2x on both sides, you will have x less than negative 4. So if you divide with a negative number on both sides, you have to change the inequality sign. If it was greater than, it becomes less than. If it was greater than or equal to, it becomes it was less than or equal to, it becomes greater than or equal to, and vice versa. So that's the only difference. The other procedures are the same. The only difference is it only comes in if you are dividing or multiplying with a negative number on both sides. So I'm running out of time because of the space on my phone is very limited. So to do some examples, we have maybe solve for x in the following inequality. We have a x plus 2 greater than or less than 6. So to solve this inequality, you have to transfer all the like terms on one side. You have to move all the sides on one side. So all the like terms on one side. So we have x equal less than 6 minus 2. Remember, when you transfer a term from one side, the sign have to change. So this will be x greater than less than 4. That will be the answer. And for the second one, we can have negative 2x plus 4 greater than, less than or equal to 6. We're doing the same way we solve linear equations. So here to transfer 4 to the other side, we have negative 2x greater than or equal to 6 minus 4. So we have negative 2x greater than, less than or equal to 2. We are dividing with negative 2 on both sides. Negative 2 on both sides, we have x greater than, less than or equal to negative 1. Now remember what I said. If you are dividing with a negative number on both sides, we have to change the sign. So this answer is wrong. The correct answer will be x greater than or equal to negative 1. So my time. So do not change the signs. So you have to keep the inequality signs. So I'm really running out of time because of the space on my phone. So you can do some class work here. We have to solve for x in the following inequalities. A, we have 5x minus 17 greater than 18. B, we have 3 into x minus into negative x minus 2 greater than or equal to 4. And B, we have 5 into x minus 7 plus 4 less than